Okay, so you guys should have your graphing calculators. If you notice, we're going to be 0 to 2 pi. So first thing I'm going to do, since this is a graphing calculator problem, make sure, make sure I'm in radians since I am dealing with radians in my problem. Next thing I want to do is I'm just going to change my window, and I actually have already changed it. So I'm going to go 0 to 2 pi. Because all my answers are going to be between 0 and 2 pi. As far as the scale, don't worry about that. We don't really care about the max and min. We're finding the solutions, and if you notice in our equations, we're trying to find where it is equal to 0. So I just need to see enough of my graph to see the x-axis and maybe just a little bit, whatever it looks like. I just need to see this section right here so that I can find the zeros, okay, or the x-intercepts. So that's how my graph is set up, okay. So clear that out. First thing we want to do is I'm just going to show you how this would be written in your calculator. So this would be y equals 5 times sine 4x instead of a theta minus 3. So we're going to go 5 times sine of 4x. Oh goodness, I am not in the right spot. Okay, 5 times 4x. I don't know what I pushed, but 4x, close that parenthesis, minus 3. Okay, go ahead and hit graph. So we're looking for every point that it intersects, every spot at 0. So if you go to your, let's try this. Let's go to our table. We're looking for y is 0. Okay, if you notice, because of the way it's counting, I'm not going to really be able to find it in my table. So we're going to go back to this. We're going to go second, calculate. We're going to do a 0. Where am I? Okay, there's my Spidey. Okay, I'm going to take my spider, and I'm kind of using this left bound number here to help me figure out where my spider is. Okay, I'm going to take my spider to the left of my first 0, move my spider up, take it to the right, hit enter. So my first answer is theta equals 0.1609. Okay, so then I'm going to do that again. Second, calculate, 0, move my Spidey. Okay, so now, there he is. Now my spider is to the left or slightly above this next 0, and then move it, and now it's to the right or below, and hit enter. My next answer is 0.6245. Okay, second calculate, 0. Okay, this time I'm moving my Spidey to the left of this one right here. And I'm going to keep pushing over until I find him. There he is. Oops. Okay, left bound, enter. Right bound, enter. If you notice, mine has these little arrows up here. Most of them do. That 0 should be somewhere in between those two arrows. If you've got a newer one, it has the colored lines, which is really nice. It always asks you to guess, but you don't need to. 1.7317. Okay. Second calculate, 0. This method is really nice if they don't want exact answers. However, because we have to round, we're not getting exact answers. So this is limited to approximation solutions. So that's why we tend to not do this as often. If you're ever doing an assignment and you wanted to check your answers, you could always graph it and then check to see if your exact solutions are the same. The approximations would be the same. Okay, so this isn't very hard. It's a bit time consuming. One. Okay. But as far as the actual math is concerned, the trickiest part maybe is to type it into your calculator. Okay, I am almost done. 0.8733. Just one more. Okay, so those should be my, tens, hundred, thousands, 10,000s. I'm trying to think of what I have you grounding on your assignment. I think I have you at 4 decimal places. Sorry, I'm checking my answer key real quick. And I'm looking at the wrong problem, so I'm going like, my answers are completely different. Oh no. Let's see. Okay, so this is 4 times, so I have 1, 2, 3, 4, 5, 6, 7, 8. That looks good. I said this is number 12. That one's good. That one's good. Oh, okay. I'm just struggling. My answer key, they're not in any particular order. They're kind of all over the place. So I'm looking at mine going, well, I didn't get this one next. Sorry. Woo, struggle. Okay, so that's how you would do that one. This video ended up longer than it should have been because I struggle. I just want to look up how you would set up number, let's say, maybe 15 in your calculator. Okay, so you have 5 cotangent x minus 6 sine x equals 0. Okay, so cotangent we know is 5 times 1 over tangent x minus 6 sine x equals 0. You could do one of two things. You could do 5 times, you could do your alpha zoom and set up your fraction, then minus 6 sine x, and that's obviously y. If you don't have that option, you could do 5 times parenthesis 1 divide tangent x minus 6 sine x equals y. Okay, so either one of these would be the proper way to stick it into your calculator. Just be careful on those. And this one is a little like it's a little hard to tell how many answers you get because you have cotangent and sine there together, but it's the same idea. You're looking at where it crosses and you're finding those solutions. Number 14. Sorry, just little things on these. So 14, you have 9 sine squared 2 theta minus 1 equals 0. So you'd have 9 sine squared 2 theta equals 1. Divide by 9. So sine squared of 2 theta equals 1/9. Square root sine squared 2 theta equals 1/3. Oops, that's gone. So sine of 2 theta. Oh, what am I doing? I'm solving this. We just type that in your calculator. I'm so sorry. Brain is not working. It's wanting to do math. I don't know why. Well, I do know why, but type this in your calculator. 9 times, okay, sine 2 theta or 2x squared minus 1. Okay, so this whole thing right out here is what's going to be squared. Do not put sine squared parenthesis 2x. This is the proper way to stick it in your calculator. Yep. Anyway, I'm going to call it a day. I think I'm done making videos because apparently I'm struggling. FYI, on 9 or 14, you're going to get 1, 2, 3, 4, 5, 6, 7, 8 answers. So just be aware of that. Again, that comes from this idea. Technically, I would have plus or minus. So Yeah, there's going to be quite a few answers there. So good luck. If you have questions, let me know. I will make complete videos of any problems you'd like. And have a great day, great weekend, great week. And I will have everything new for you on Monday. So, ta-da! Bye.